Nice introduction, Mr. Moses. I will dive right in and start my presentation. So I'm going to start by defining satellite-based crop health analysis. This is a technology that allows the farmer to perform real-time crop monitoring by analyzing satellite images of different crops and fields to determine both negative and positive developments of the crops. By getting the different vegetation index of a farm over a period of time, the farmer is able to determine whether there is an improvement in the farm or whether there is a deterioration in the farm. From this analysis, the farmer is able to take any corrective measure that may be needed in the farm. On this next slide, we are going to have a look at the popular satellite-based farming indices. The first index we're going to talk about is the Normalized Difference Vegetation Index, or the NDVI. NDVI is a standardized way to measure crop or vegetation health. When we have high NDVI values, it means we have healthier vegetation, and when we have low NDVI, we know that we have less or no vegetation in that area. NDVI helps in detecting areas of concern within the field faster, enabling the farmer to spend water, crop nutrients, and pesticides more effectively. The second index we are going to look at is the Normalized Difference Water Index, or the NDWI. NDWI reflects moisture content in plants and the soil. It's therefore a very good proxy for plant water stress. The early detection of water stress can prevent many of the negative impacts in the crops. The third index we are going to have a look at is the Normalized Difference Red Edge, or the NDRE. This index gives a full picture of chlorophyll content, which is one of the main nitrogen indicators, and thus helps with fertilizer application mapping. You should use NDRE you should consider using NDRE if you have interest in mapping variability in fertilizer requirements or foliar nitrogen and not necessarily nitrogen availability in the soil. On this slide, we have a look at one case study. On the screen, we can see the case study is for a field. So it's for in-season yield prediction in Kenya. On the left side of the screen, we have a crop health map for a 300-hectare commercial vegetation farm. That's also a very good example of an NDVI map. In the middle, we have a graph of the crop growth model and yield estimation. From this, we have two curves. The red curve shows what we had estimated, while the blue curve shows the actual curve for that growth season. So what advice did we give to the farmer? What did the farmer get from all of this? So the commercial farmer was able to predict the yield in season, was able to reduce and increase inputs accordingly, thus saving 9% on fertilizer and pesticides. So the key interventions were: one, highlighted low organic matter content across the farm, and also change of planting fertilizer regime to our custom organic blend. So on the end, we can see a dashboard. So the crop was beans. The area was 5 hectares. We had estimated the farmer would get around 8,000 kg, but the actual amount was 8,500 kgs. So we can see actually our yield estimation is correct, near correct. The second case study is for an irrigation system performance analysis in California, USA. On the left, we have GIF image displaying. So it's showing the different images for different time periods. And on the right, we have an image where we have circled areas of concern. These areas were detected from the maps. You can see playing. The circled areas were the areas where the irrigation lines had malfunctioned. For this farm, the farmer had noted a decline in production and had consulted us to have a look at the farm and do some analysis. From the information we gave the farmer, he was able to direct technicians to malfunctioning irrigation lines without the need for slow and expensive on-the-ground scouting for the 600-hectare farm. Thus, he saved around $600 in labor cost. In conclusion, we can see that satellite-based crop health analysis have many advantages. Namely, the first one we can name is the near real-time aerial view of your farm will enable faster decision making and will also enable reduction of cost through variable rate application of inputs. Thank you. I'll now hand over to Mr. Moses to continue.
Thank you, Kevin, for sharing the valuable insights on satellite-based crop health analysis. I'm sure you've gotten everybody interested and curious to want to find out more. Without further ado, I will ask Dr. Fabio Vescovi to commence his presentation on the Airbus VHI, which he has been working on for the last few years. So Dr. Fabio will give you the access to the to my controls, to my mouse and keyboard. You may now proceed.
Hello, good afternoon, everybody. I hope you hear my voice.
Loud and clear, yes.
Okay. So, thank you, first of all, Moses.
Sorry, we seem to have some trouble hearing you, Dr. Fabio. There seems to be some difficulty with the connection.
Thank you, Kevin, for this event.
Fabio, can you hear us?
And for the last presentation, really interesting, an amazing presentation. For I've seen many presentations generally on remote sensing cable, concrete, cable connection. Yes, I hear.
Okay, please proceed. Yep.
I hear you. Do you hear me?
Yes, I hear you.
Okay. Okay. So this is not the slide. Maybe. Okay, here you come. Let's come to. Okay, the first slide is. The topic of this presentation is about the Vegetation Health Index, which is a kind of evolution of the NDVI you have seen before, even though the logic is more or less similar. I mean, it is a satellite-derived index applied to vegetation and agriculture. And with this index, it is possible to detect the health status of your crops, and especially in case of drought, the monitoring of drought with this index is particularly successful. I belong to the company you see on the bottom right corner of this slide, Airbus. Airbus does not manufacture only aircrafts. You might have seen, probably you might have heard of this company as well, and you have seen aircrafts. But Airbus also manufactures, designs, and applies satellites. And my branch of the company is in UK. We are a big European company, and we are applying satellite data also to agriculture and disaster. The next slide, I think, to have control with this. Let me see if I can proceed with the next slide. In the next slide, if I can see it, I should present the team responsible for the organization and the management of the project with the project concerning the VHI. I can't see the next slide. How is it possible to proceed?
So I'm presenting the next slide with the team, the IPPI team.
Oh, I don't see it on my screen. Anyway, if you guys can see the IPPI team, you should see 4 people. I don't see them. The first one is Professor Ogembo. Professor Ogembo was one of the most important key high-profile engineer in this project. He was teaching at the University of Nairobi. Unfortunately, Professor Ogembo, after so many years of engagement with Airbus in project in agriculture, he passed away a few months ago, and we all remember him as one of the most important key elements of this project. The second person in the team is Oliver Onyango. He is a surveyor and the director of Building Africa. Building Africa is an organization, an NGO based in Nairobi, which was extremely key and instrumental in the organization of the project. The other 3 chaps you can see in the pictures, we are all Airbus staff, and me, I'm in the middle, Fabio, and at my left and at my right, you can see another couple of colleagues of mine who are collaborating with me in this project.